Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have an amazing problem for you guys. What we're talking about. So let's go ahead and read the problem statement, guys. So the problem is called "Find leaves of binary tree," right? So this is a very good problem. So let's go ahead and read it. It says, given the root of a binary tree, right? Collect a tree's nodes as if you were doing this, right? I'm saying, so it says collect all the leaf nodes, right? Remove all the leaf nodes. It says repeat until the tree's empty, right? So awesome. So pretty much we're gonna be given this tree, all right? And then our job is pretty much to remove the nodes, I'm saying, pretty much in this fashion, right? So pretty much, uh, it says collect all the leaf nodes, right? Remove all the leaf nodes and repeat until the tree's empty, right? So this visual really illustrates everything that you need to understand, right? So pretty much they're saying that also remove the what they're doing, guys, right? They remove, right, the original leaf nodes, right? After they get removed, right, you're left with only two, right? So 4, 5, and 3, right? They get removed because they're leaf nodes, right? That's what we're doing. I'm saying after they get removed, right? The next thing that they do, right? They left with two, right? Two's I'm saying we got 1 and 2 in the tree, and two is a leaf node now, right? Because now what I'm saying after two it's a leaf node, we remove two, right? And then we're left with one as the leaf node, right? And then once the leaf node, we remove it, and then we says repeat it until the tree is empty, right? After that, we're done, guys. So you see how they're, pretty much categorized, they're organized, what I'm saying? Just like that, right? So 4, 5, and 3, right? They're in the same set of node. They're in the same list, right? You know what I'm saying? Because they got removed at the same time. And then 2 was removed, right, by itself, right? Because there were no other nodes that were leaf nodes at the time when 2 was a leaf node and was removed, right? And just like 1, right? 1 was removed because he was the only node, what I'm saying? So that's why by itself, guys, right? So hopefully you guys kind of understand what they're kind of asking us to do, right? So pretty much you remove the leaf nodes and you keep doing that, and I'm saying one step at a time until the tree's empty, right? So you remove a set of the leaf nodes, right? I'm saying, and then after you remove them, you're left with other nodes that become leaf nodes, right? And then you uh those leaf nodes themselves, right? You remove them as well, and then you keep doing that over and over and over again, right? I'm saying until the tree becomes an empty tree. You know what I'm saying? Because until the tree's empty, guys, right? So you see this one, it's a pretty simple one because that's the only node in there. So after we remove it, right, we're left with an empty tree, and then now 1 is the only node in there, right? So pretty much, no, yeah. Hopefully, you guys kind of understand that. So pretty much, guys, the how can we go about solving it, guys? You know what I'm saying? How can we remove nodes? You know what I'm saying, and how do we collect the nodes, you know what I'm saying, in such a manner that we kind of okay, organize them, you know what I'm saying, in such a way that they get, you know what I'm saying. Yeah, so the intuition that we're gonna do, guys, let's just go into my drawing board, guys, what I'm saying, because get we're gonna do a lot of great things right now, right? So let me, all right. So yeah, like I was saying, guys, right, how can we get that in this manner, guys? So what kind of traversal that we need to solve this? I'm saying because I'm thinking about, I'm saying, is it a level order traversal? Level, I'm saying, no, it can't be because, I removed 3, but 2 is still there, right? 2 didn't get removed at the same, 3, 2 didn't get removed at the same time when 3 was removed, right? Because 4 and 5 were removed, but they're not in the same level as 3, right? I'm saying, so I'm not, what kind of, yeah, level order, I don't know. Maybe I don't think that's gonna work for this one, right? Pre-order. Um, hmm, interesting. Post order and order traversal. What kind of traversal can allow us to obtain it in such a manner, right? So 4, 5, 3. Okay, they're leaf nodes right there. Okay, what do they have in common? Mm, the things I think they have in common that can pretty much they have the same height, guys, right? Same height. If you guys know what height is, right? It's the number of edges from height of a node, right? It's the number of edges from that node to the deepest leaf, right? So uh, the height of those nodes, right? They're all 0, right? You know what I'm saying? All zeros, right? I'm saying, right? The height of 2, right? What is number of edges, right? So it's only one. So the height is height of one, right? And then so they get removed, right? Because they all have the same height, right? Because they're all leaf nodes, you know what I'm saying? Originally, and then a height of two is one, height of one, right? Is gonna be a height of what, guys? It's gonna be one, two. It's the number of edges, right? Two, okay. And yeah, the height of one is what, guys? The height of one is two, right? So hmm, I think I'm getting somewhere here, right? So if I do a post-order traversal of the tree, right? I'm saying obtain the height of my children, right? I can pretty much calculate my height and I can know which I'm saying that's how we get the height, guys. I'm saying we don't know how to get the height, right? So I calculate my height, right? And I check in which collection do I belong to, right? So I can pretty much keep track of the nodes that all have the same that are leaf nodes at the same time. I'm saying pretty much it all has to do with the height, guy. It looks like, right? Because you know, 4, 5, and 3, right? They all of them have a height of 0, right? I'm saying that's right. After you remove those nodes, set of nodes, right? You're left with 1 and 2 as the nodes in the tree, right? And then 2 is the leaf node, right? I'm saying, and 2 is the only node I'm saying that had a height of 1, right? So because of that, I'm saying it's in a section by itself, and then 1 is in a section by itself because it's only node height of 2, guys, right? Yeah, so after we remove 2, we left with 1, right? So that's kind of an intuition, guys. So it has to do with height. So we're gonna pretty much we're gonna thinking about have a map, right? That can pretty much the height can be the key, right? And then the value can be a list that has pretty much, which is the list of nodes that share the same height, guys. Because of that, we can collect all the different nodes that have the same height, guys, and keep them organized. And then we can pretty much return that as the output, guys. So pretty much you tell us something like that, right? So pretty much, I'm saying the height of 0, right? I'm saying is pretty much what it's gonna map to a list, right? So pretty much the nodes that have a height of 0 is 4, 5, and 3, right? I'm saying by handwriting, guys. Sorry. And then a height of 1, right? There's only one node with a height of what, guys? A height of 1, guys, right? So height of 1 is 2. You know what I'm saying, and then 2, the only node is 1, guys, right? So just like that, guys, we have access to all the list, and we will just return that list, guys. I'm saying as easy as that, guys. So hopefully you guys will be able to understand the intuition. Let's quickly go ahead with the code, guys. What I'm saying, I think we got it covered. So the code is going to be relatively simple. So what we're going to be using, guys, we're going to be using something extremely good, guys. So all right, yeah. So what we're gonna have here, guys, we're gonna have a map. If you said that the integer, right, is gonna map to a list of integer, right? I'm saying pretty much to keep track of all the different nodes. I'm saying so it maps to the list of the nodes that belong to that height, guys, right? Right. So now, guys, what we're gonna do, we're gonna pretty much use a helper function, pretty much, you know what I'm saying. Yeah. So yeah, let's call it helper, right? And then we're gonna pass in the root, guys. And we also pass in the map, guys, right? And after we do that, right, you know what I'm saying, we're gonna return. Um, so pretty much we need to, and now I'll apply the logic after. So pretty much just copy that saying, okay, let's go to results. This is what's gonna have a result, right? Array list, right? Okay. And then I'll apply the logic after, where we're gonna retrieve the result from the map, right? Okay. So now, guys, this is where it gets really fun, right? So we're gonna pretty much, guys, our calculate our the function that's gonna calculate the height of all the nodes, guys. I'm saying help us in calculating the height, right? So pretty much we have tree node, I'm saying root, and then we're gonna also pass in the map, guys. The map is gonna be important. It's gonna help us a lot, right? All right, so root is null, right? We return, guys, -1, guys, right? Okay. And after that, guys, what we're gonna do, we're gonna pretty much go get the height of our left side, right? Pass in our left side, left child, right? Also pass in the map. We do the thing for the same thing for the right side, guys. Um we pass in the right side as well, right? And then we also pass it on the map, right? And after we do that, right, we get our height, right? Which is gonna be the that max, right, of our left side or the right side, right? I'm saying, and then plus one, guys, right? To account for that node, right? I'm saying that edge that they share between them, right? Yeah, so we get the maximum out of the two, right? Because we said what the height is, right? And it's the number of edges. Height of a node is the number of edges from that node to the deepest leaf, right? So this is what we know, in the deepest one, right? And after we do that, guys, this is where the map comes in, right? We check, right? Does the map contain that height, right? Has it seen it yet, right? If it does not contain that, right? We're pretty much going to allocate memory for it, guys, right? A new array list. All right, after we do that, guys, we can easily just do map that get the height, right? I'm saying get that list, right? And add that node's value to it, man. I'm saying. Okay. And after we do that, man, we just return now, right? Return our height to our parent, right? I'm saying that called upon us, right? So we need to return the height, guys, right? And yeah, just like that, guys, I think we're in good shape. So you just pretty much, like I said, what I'm saying, all the nodes that share the same height, right? They're gonna pretty much be in this remove at the same time, right? I'm saying they're gonna be in the same set of elements that I'm saying. Yeah, so 4, 5, and 3, I'm saying share the same height. That's why I know they're all leaf nodes. That I'm saying they get removed, and then you're left with 2. 2 is the only node to remove 2, right? 2 has a height of 1, right? And that's why 1 by itself, right? So that's kind of get the key takeaway, guys, right? We do a push. I'm tripping. I didn't apply the logic to. So now after we do that, guys, the next thing I need to do, forgot to do it. So pretty much we get all the stuff from the so res is gonna be map that values, right? What I'm saying, and we just add it in there, guys, right? So what is it? So res that add I forgot what it's called. So val, let's call it val. And then we add every list, right? We add every list to the output result, right? I'm saying it's gonna hold all the pretty much lists, right? I'm saying, and yeah, we're still good now, right? I think everything should be fine. Let's press submit. I'm gonna show you guys. Yes, it's a very, very good, efficient solution, guys. So it's a very, very good one, guys. I like it a lot. Yeah, so if you guys understood the thought process and you guys found value in this video, make sure to let me know in the comment section, and I would really appreciate that. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next one.